With question 36, we have this right triangle shown in the plane above, and we're going to transform it in the plane by being reflected about the line y equals negative x and then rotated 90 degrees clockwise about the origin. Which of the following could be the result of this transformation? So we're just going to zoom in a little bit on that initial triangle, and we want to reflect it over the line y equals negative x. If I draw in the line y equals negative x there, and if I go ahead and reflect each of the vertices over that line, then we see that we'll end up with a triangle that looks something like that. So after the first transformation, we're left with this triangle as we see it here. And if we wanted to, we could give some coordinates to those different vertices. So for example, if we had 2, 1 is the right angle, then 2, 3 would be the angle above that, and the angle to the right, the vertex to the right would be 5, 1. So when we reflect them over the line y equals negative x, let's see what happens. So the point furthest to the bottom became negative 1, negative 5, which we can see that what happened was that we flipped we inverted the coordinates, so from 5 to 5, 1 to 1, 5, and then they both became negative. So for the coordinate 2, 1, we're going to flip them. They become 1, 2, and then make them both negative would be negative 1, negative 2. And the final point, which was 2, 3, we flip them. We get 3, 2, make them negative. We'd have negative 3, negative 2. So you can see what happens when you reflect an object over the line y equals negative x. You're going to invert the x and y coordinates, and then everything becomes negative, the opposite of what it was originally. Alright, now we want to do something similar, or we want to rotate this 90 degrees clockwise about the origin. So if we draw in our point there, our triangle there, as a result of the first transformation, and we want to rotate this 90 degrees about the origin. Well, one way to think about that is to draw a line segment from each vertex to the origin. And for example, in that corner where the right angle is, we have the coordinates negative 1, negative 2. X is negative 1, y is negative 2. So that line segment has a slope of positive 2. Since it passes through the origin, it would just be the y-coordinate divided by the x-coordinate, so it would be negative 2 over negative 1, or slope is 2. Now, in order to have a slope that is 90 degrees perpendicular to that, its slope would have to be negative 1/2. And again, since it passes through the origin, it would have to have a rise of 1 and a run of negative 1. Sorry, it's going to have a rise of positive 1 and a run of negative 2, so that it would be change in y over change in x, or negative 1/2. And since it passes through the origin, again, the y-coordinate would be 1, the x-coordinate would be negative 2. Well, right away by doing this, we know that the answer cannot be either A or B, because neither of them have coordinates in the second quadrant. Then again, we're going to take the other vertex, which originally was coordinates negative 3, negative 2. Since it passes through the origin, it would just be the y-coordinate over the x-coordinate, which is 2/3. The perpendicular slope then would have to be negative 3/2. And since it also passes through the origin, it would just be the y-coordinate over the x-coordinate. And so its coordinates would be negative 2, 3. Now, if you notice, comparing that to the original diagram, it really is almost a reflection just over the y-axis. The third point, which has coordinates negative 1, negative 5, passes through the origin, so its slope is negative 5 over negative 1, which is 5. So its slope is negative 1/5, and its point will be negative 5, 1.